Today I'll discuss the chapter Arithmetic Progression, which is called in short AP. So, what is an AP or arithmetic progression? It is a special sequence of numbers where the next term, each term is obtained by adding some fixed amount to the previous term. So let me explain with the help of an example. Suppose I start with the number 2. Then the next term I'll be adding say some fixed amount, say 3. So 2 plus 3 is 5. Then next I'll add 5 plus 3, 8. Then 8 plus 3, 11. So in this way I can, if I form a sequence, then this sequence will be known as AP. So that is actually, so you see, and we can, if I write the number of terms in this way, first term A1, second term A2, third term A3, in this way, fourth term A4, in this way you can go up to nth term. Or if n is a finite number, it will be finite AP, and if it goes up to infinity, it will be infinite AP. So here you see, what we observe, A2 was A1 plus some fixed amount, which is known as D. That is where D is known as the common difference. Then the third term is obtained, A2 plus D. Fourth term, A3 plus D. In this way it will go. So you see, I am adding a fixed amount which is known as the common difference to the term to get the next term. So this is the speciality of the this arithmetic progression series or sequence. So you see, so how will you know whether a given sequence is in AP or not? For that we will see what is that. From this what we see that A2 minus A1 is D. Here A2 minus A1 is D. Here also A3 minus A2, A3 minus A2 is also D. A4 minus A3 is also D. And if I go on in this way, AN, and suppose next term say AN plus 1. Let me take n plus 1 in term. Then it will be AN minus 1 plus D, and it will be AN plus D. So from each I am getting this thing, that is, it is AN plus 1 minus AN. From this I will be getting, will be equal to D. Also from here I will be getting AN minus 1 is equal to D. So this is the actually main feature of the arithmetic progression sequence. That means this I can say, this is D. Or I can say, if this is satisfied for any sequence, that is AN plus 1 minus AN is some constant, then we can say that the sequence is in AP. Sequence is in AP or arithmetic progression. Or this is a general one. This is the general condition. General condition for a sequence to be in AP, but we can, for in particular, we can look for these two also. That is these two, that is A2 minus A1 D, A3 minus A2 is also D. So also in that way also we can say, so if A2 minus A1 is equal to A3 minus A2, then the sequence is in arithmetic progression. So we have to check this in particular. If first three terms of any sequence is given, first three terms, then we can very easily check this. So and if this is not equal, then we say this sequence is not in AP, and this is in general. Okay. So, and it is customary to express the first term A1 as A. So for a AP, the two parameters, that is, one is A, that is the first term of the sequence, first term, and the other parameter is D, that is the common difference. Common difference, okay. Let me erase this. Let me write it properly. Common difference. That is, this is the common difference. This is D actually. So if I know these two things, A and D, I know all the terms of the sequence. And also there is another parameter we should know, N, which is means the how many terms are there, number of terms, N. Okay. So these two things we have to remember, that is, if this condition is satisfied, then the sequence in AP, and this difference will be, this fixed amount will be known as the common difference, and first term A1 is the first term, that is, A1 is the denoted by A, and the common difference, that is A2 minus A1 on this, is known as D, and in general we say this. Now let us give some example where you can check these things. So let me take one sequence. I am taking a sequence 2, 4, 8, 16, many terms are there, I don't know how many terms are there. So I have to check whether this sequence is in AP or not. So for that I have to check this condition. So what is it? This is your A1, this is A1, this is A2, A3. First three terms are sufficient for checking this. So let me first find out A2 minus A1, that is 4 minus 2 is 2. Then let me find A3 minus A2, A3 is your 8 minus 4, that is 4. So they are not same. So we write, since A2 minus A1 is not equal to A3 minus A2, therefore the sequence is not in AP, is not in AP. In this way check. Let me take another one. So here what will okay, so let me take another one, another example. Two 5 by 2, 2, 5 by 2, 3 and 7 by 2, etc. So here also I have to find A2 minus, this is second term, A2 is 5 by 2, minus first term is 2, so it is coming out to be 2, 5 minus 4, half. And here A3 is 3, second term A2 is 5 by 2, so it is 2, 6 minus 5, 1. So here they are coming out to be same, both the difference equal to half. So therefore we say the sequence is in AP with the first term A is equal to this 2, A1 is your first term A, and the D common difference is this one. So D is equal to half. So in this way we check. So here d is a fraction. Now again I am telling you this, you see these two numbers a and d, they are real numbers, a and d. That means they can be either rational or irrational, positive or negative, fraction, integers, everything they can happen. But this number of terms, this only has to be a natural number. And because it is a counting number, so only this n is natural number and these two are real numbers. Real numbers. Now let me take another example. Let me take a sequence, half, 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 etc. So here a2 minus a1 is half minus half, that is 0, and a3 minus a2 is also half minus half is equal to 0. So since a2 minus a1 is equal to a3 minus a2 is equal to 0, therefore the sequence is AP, in AP, with a is equal to half and d is equal to 0. So the d can be 0 also, and when d is 0, the terms of the sequence is same, is a constant. That is, all the terms remain same, neither increase nor decrease. And you remember, when d is greater than 0, then only the terms will increase, and when d is less than 0, the terms will decrease, and when d is equal to 0, terms remain same. This is the basic trend. Okay, and so this is a rational number. In the previous case also we got d to a rational number. And let me take, and in the very first example where a was 2 and d was 3, that was positive integer. Now let me take another example where I show d can be irrational also. So that I can take you as root 2, root 8, root 18. Root 2, root 8, root 18, then root 8, 18, and then I think it's 32. 32. In this way, the sequence is given. So here, let me first, what to do now, you see. For checking this, I have to convert them into mixed surd. That means these are a pure surd. That is, so how we can change this is root 8 can be written in this way, you know. 4 into 2, that is, this 4 will come out as 2, so 2 root 2. Similarly, root 18 can be written in this way, 9 into 2, so 9 will come out as 3 root 2. Similarly, 32 also can be written in that. These are called mixed form and these are pure form. So for checking this, first of all I have to convert all the terms in the mixed form. So a2, now I will be checking a2 minus a1. So this was your a2, root 8 was a2, and this was your a3. So a2 is 2 root 2 and a1 is root 2, so it is root 2. And a3 minus a2, a3 is 3 root 2 and it is 2 root 2, so this is also root 2. So therefore, or since a2 minus a1 is equal to a3 minus a2 is equal to root 2, therefore the sequence is in AP. AP with first term a is equal to root 2 and the d is also root 2. So because this is your d. So in this sequence, this is in AP. The first term is also an irrational number and the common difference is also irrational number. Okay. Okay, now next, let us derive a formula. You see, suppose I have a AP, in AP is there, that is, so I will be adding a fixed amount. Say I have taken A to be 2 and D say I have taken 3. So A starting with 2 and then I will go on adding the common difference. So 2 plus 3, 5, 5 plus 3, 8, then 8 plus 3, 11. In this way it will go. Now suppose I have to find say 70 or say 61th term. 61th term of the sequence. Then it is not possible to write each term, there's 11 plus 3 and go on adding up. It's not possible to reach up to 61 term. It is a very long tedious method. So for this kind of situation, then we need some formula. Now you see, so if I need a formula, then so that I can find out directly this. So for that I have to find a formula. So how will, let us derive the formula first then. So what is our first term is your A in the sequence, AP sequence. So it is A plus D. A3 is A plus 2D. It's not because I'll be going adding D. So A3 is A2 plus D. So A plus D plus D, A plus 2D. Then A4 will be A3 plus D. So it is A plus 3D. So in the very beginning I have shown you how we are getting the next term simply by adding the common difference. Okay. So if you observe the pattern, so you see how can I write this one? I can write this one as this 1 minus 1 into D, and this can be written in this way. This 2 minus 1 into D. I will be writing so 2 minus 1 into D is 1D, and similarly this 2D can be written as 3 minus 1. 3 minus 1 into D, and similarly this 3D can be written as 4 minus 1. So this is the pattern we have seen. So this, the suffix 1 means the number of terms. So A1 is A, 1 minus 1, 0D. A2, second term, A plus 2 minus 1D. When it is 3, 3 minus 1, when it is 4, 4 minus 1. So if you observe the pattern, the number of terms minus 1, number of term minus 1 into D. So in that case, I'll be able to write the nth term will be A plus number of term n minus 1 into D. So this is the formula. First formula of AP chapter. So this formula we have done simply by observing the pattern. So now you see this formula will help us finding in the 61st term. So what will be the 61st term of the AP? Simply I'll put the values. It is this one now. So 61st term, that means n is equal to 61, is not it? So that is 61st term is A61. A, what was A? A was 2 plus n is your 61 minus 1 and D was 3. So I simply put the values in the formula. So this is 2 plus 60 into 3. So it is 182. So so if I simply know the first term A and the common difference D, I will be able to find the value of any term using this formula. So if now I have to find, say A91, so it will be A plus 91 minus 1 into D by this formula. N is your 91, so n minus 1D. Put the value. A was your 2 plus 90 and D was 3. So 2 plus 270. So 272. So in this way we can find out value of any number of term. Any number term. So this is the formula we have to remember, which you have derived simply by observing. Okay.